Hello, everyone. Welcome back. Now, let's discuss the first component in Docker architecture, which is Docker client. Whenever people start learning Docker, they usually focus on commands such as Docker run, Docker pull, Docker ps, stop, and Docker images. But have you ever wondered what actually receives these commands? The answer is the Docker client. So, the Docker client is the component that users interact with directly. Whenever an admin or a developer or a DevOps engineer executes a Docker command, they are actually communicating with the Docker client. Just think of the Docker client as the front end interface of Docker. It accepts commands from users and forwards them to the Docker daemon for execution. One important thing to remember is the Docker client does not perform the actual work. It simply sends requests. This is a very important concept because many beginners assume that the Docker client creates containers or downloads the images. It does not. The Docker client is only responsible for receiving user instructions and passing them to the Docker daemon. So we'll discuss about Docker daemon component in the next lecture. So let us focus on Docker client. The most common Docker client commands are Docker, let us say Docker pull Nginx and Docker run Nginx and Docker ps, Docker stop and the container ID, the container which is running actually, and Docker images. So whenever you type these commands in the terminal, the Docker client receives them first. The client then sends the requests to the Docker daemon. So let us take the same restaurant example. Let's use the simple restaurant example to understand this. Imagine you walk into a restaurant, you sit at the table and place an order. For example, you say, I'd like a pizza. As a customer, do you enter the kitchen and prepare the pizza yourself? No. You simply place the order, and the kitchen staff and the chef perform the actual work. Docker works exactly the same way. Here, the customer is Docker client and the chef is Docker daemon. The customer places the order, the chef prepares the food. Similarly, the Docker client sends the requests, it accepts the commands from the user and sends the requests to the Docker daemon, and the Docker daemon performs the operations. This makes Docker architecture much easier to understand, right? Let's see what happens when we execute a command. Suppose I type Docker run Nginx. The Docker client receives the command. At this point, the client understands that the user wants to run an Nginx container. Then the Docker client forwards the request to the Docker daemon. The Docker daemon processes the request and it creates and starts the container as well. So notice something important here. The Docker client never creates the container. It only sends the request. The Docker daemon performs all the actual work. The common flow looks like this. You're typing a command, Docker run Nginx. It is received as an instruction by Docker client, and Docker client sends the request to Docker daemon, and Docker daemon processes the request and creates a container. So this communication happens within milliseconds. As users, we usually don't notice these internal steps because Docker makes everything look seamless. Most commonly, we interact using the Docker CLI with Docker client. So CLI stands for command line interface. So you can type, the most common commands like Docker version, Docker info, Docker images, Docker PS, Docker run. Each of these commands is accepted by the Docker client. The client then forwards the request to the Docker daemon. So in enterprise environments, applications and automation tools can also communicate with Docker using APIs. This allows the tools such as Jenkins, GitLab, CI/CD, Ansible, or Kubernetes to interact with Docker programmatically. So why is Docker client important? The Docker client provides a simple way for admins and developers to manage containers. Without the client, users would have to communicate directly with the Docker daemon. The client here acts as a bridge between users and Docker's internal services. So this simplifies operations and provides a consistent interface for container management. Let's make a middleware admin scenario here. Suppose you want to start a Tomcat container. You execute Docker run Tomcat. The Docker client receives the command and sends the request to the Docker daemon. The Docker daemon checks for the Tomcat image. If required, it downloads the image. The Docker daemon creates the container, then Tomcat starts running. So as administrators, we only execute a simple and single command. The Docker client and Docker daemon handles the rest, right? That would be all. In the next session, we'll look at the Docker daemon, which is the component responsible for performing all Docker operations behind the scenes. See you in the next lecture.